Back everyone, today we're going to be working on another programming project here. I've already kind of jumped the gun a little bit because I'm pressed for time. I have to leave in about an hour, so we'll see how far we can get here. But the plan for today is basically to make a program that'll automatically figure out math for splitting a bill when things get a little complicated. So for example here, I went to dinner with some friends and we paid in cash because their system was down, and different people paid different amounts of cash in the restaurant, and also the price was different for each person. And so basically we're going to be working on a program today. I got pretty close with the spreadsheet, but there were some weird quirks I couldn't work out, where basically I was, these are all kind of the final prices owed, where a negative means you get money and positive means you pay. And I was trying to just have like a payment matrix where you could manually like put in these values and then figure out like the cash in from each person, the cash out, and make sure that these all equalize. But then it gets just kind of annoying. So I figured this is kind of a useful thing to have in the future. There'll probably be other times where I could use something like this. So basically we're going to make a program today that's general, and so I've kind of gotten started here already, where we have the CSV file that has basically the same thing from that one spreadsheet. It's just the name and then how much that person owes. So like for me, I owe 46 bucks. We've already figured out that math, luckily. And so like these negative numbers mean that these people need to get 83 bucks. So basically the program's going to read this in and then figure out the minimum number of payments to basically send, so it can spit out a list of individual Venmo transactions of like kind of like edges in this graph of like, okay, Troy pay whoever, blah blah blah, or maybe even I split my amount I'd owed to multiple people so it evens out. Basically we're going to be making that. So I don't have a lot of time, so this is going to be kind of like a hack together approach where we just kind of choose, like kind of just do math. There's definitely a better way to do this, where if you find, like, let's say there's someone who's owed like someone's owed an amount where two other amounts sum to that, then basically you have an easy transaction where you just have these people pay this one person. And so basically you limit the number of splits you have to do between a single person owing a certain amount. So yeah, that's pretty much it. I just got started with this file, and then I just copy pasted some code from the CSV crate for Rust. And so basically we have our struct here, which is just the same thing I just showed you, which is all of this stuff. And this just parses it and then prints it out to make sure it's working right. So we have this. It's super general, so you could plug in any kind of CSV you want in the future. So yeah, let's get going here. So right now we're just printing this out. Probably going to want, I'm going to call this parse and have this be, and then we're going to change out this so that we can just take in any file, right? And then up here, and this is going to return, instead of this anyhow result, a vec of record. So we could do this in a more functional way, I'm sure, with this for loop. Deserialize, okay, whatever. Right, but we'll just do kind of a simple imperative approach here. Right, okay. Vec record. What are you? Okay. Sweet. So paranoid, we'll just make sure this works. Okay, cool. So we get the same thing, parsing works. And so now we're gonna have to do probably some things with matrices to store for each person who they can pay. There's definitely a good Rust crate we could use for that. Or we could just kind of hack our own thing. Yeah, no, we'll hack our own thing. It's fine. Okay. Okay, so I think our approach here, it's going to be pretty naive. Basically, we get all the people who owe a positive amount, and then we're going to match them up with someone who is owed more than how much they have to pay. And that'll be the first approach, and that'll get rid of quite a few people. So like I'll pay Jeffrey, and then Ashwin maybe. Because actually these two amounts, or no, Ashwin's owed. Basically, yeah, these two amounts are pretty close to summing to this. And so that'll get rid of some of the people, and then with the remaining people who still owe money, then we can just split out their payment amongst whoever. Or maybe if there's one person, then they're the poor person who has to do like 10 Venmo transactions to equalize everything. But that's fine. So, kind of need, It's a good thing we're not mutating this, right? Because we're going to have a double loop here. So actually with Rust, we're going to have basically a borrow of this record struct, and then we're going to be borrowing again on the inside for the inner loop. So we wouldn't be able to mutate this at all, which luckily kind of works out for our problem set. Otherwise, we'd have to use cell or something weird. Okay, so this can be B. Oh no, we are going to want to mutate this. That's annoying. Okay. So this will be source. Right, and then we're going to clone it, and then basically this is going to store, we're going to have to derive clone here. Right, so we're going to clone source, and this is going to store, basically then we're going to actually change owed depending on when we make a transaction so that everything equalizes out. And then we'll also have, we'll derive this stuff too. Transaction. From to and amount, okay? And so when we make a transaction, we'll log this so that it's easy to see, so we can print this out at the end of the program to list everything for Venmo. And then we'll actually store the current working amount for like how much each person has and what they're owed in here. Okay. So, so if A dot owed, okay, and then another thing here is that if A dot name equals B dot name, we're going to continue. Actually, do we need to traverse this the whole way? No, we don't. We don't. So I'm going to do A. Right, so this kind of functional stuff in Rust will give us the index and the current value, and then we're going to use that to loop for j in 0 to I. Yeah. And then we're going to let b equals source sub j, and we're going to borrow that so we don't move out of it. Okay, and then now I debug a, b, right, this should be a good traversal where we match up all the pairs, but it's sort of the triangle, right? So we don't loop back and look like, okay, because basically every person is either a debtor or a creditor. And so for me, because I'm a debtor, we only need to compare me with everyone once, right? Where if we do this the full iteration before, it'll compare me paying everyone else and then everyone else paying me, which doesn't make sense because I don't need anyone, no one else needs to pay me. Okay, so yeah, sweet. Okay, looks like that works. And so now if A dot owed is greater than 0, basically this is owes money. And we're going to do I don't know how to spell this, right? But basically, this is like the amount that no one cares about. So I'll set it just to 25 cents. I definitely spelled that wrong. E-P-L-I-S-O-N. Yeah, that's totally wrong. Gotta learn how to spell one day. Okay. It's gonna go down, and we'll just do EPS. Okay, cool. So if the amount is greater than money epsilon, so basically when we do our subtraction, if the person gets within this bound, then we don't care basically, because we might have floating point rounding issues where the person still is owed like 0.0001 cents, but we don't care about that. And then maybe if some of the addition works out where we can make an easy transaction where two people's amounts sum to this, sum to like less than this of what someone's owed, then we'll just call that a day and not worry about it. Okay, so so if this person owes money, and if the potential recipient is less than the negative amount A dot owed. Okay. Yeah, and this is I'm on my desktop right now, which has a different keybinds from my work computer, so I'm screwing up the auto completion on like tab versus enter. So that's a little annoying, whatever. Maybe there's a better way to do this. Yeah, we'll do it. We'll add some nice methods for this. Owed. This will be kind of like a dumb getter. So this is how much you owe is positive. Is owed is going to be negative. Okay, so if the potential we'll just call this debt and credit. That makes it a little easier. So if A's in debt, right, they have more debt than the epsilon, and their debt is greater than, now we don't need this negative, actually this can be A dot debt again, is greater than B's credit, right? That means that we can do a whole transaction here and pay them. Then we're going to do transactions. Okay, we need transactions here. Transactions, stupid autocomplete, push, transaction, we'll just create a new one. We don't need a new function or anything. We'll keep it simple. This would be from a.name. Actually, we can be cheesy here. Do we want lifetimes? Yeah, fuck it. And these, the parsing, I think these will all come from the, no, they won't. Tick F, tick T. Tick F str, ampersand tick T. I mean, arguably it'd be faster to not do this because we're basically just saving, not copying the strings around here and making allocations on the heap. But whatever. Shoot. Okay. And so the amount is going to be A's debt is going to be the amount, right? So then what we're going to do is A dot. Okay, how do we do this? So basically, this function is going to mean that minus equals. Why are you sad? Okay. And has received is going to increment that, right? Because it's negative if you're owed money. Okay, so then once we have the transaction, so A's has paid. We're just going to do this to make things a little bit more easier to read. So then this person is going to pay their to pay, and B, no, Rust. Okay, so we're just going to do dest. Dest sub I, and B mute is going to be dest sub J. So A has paid to pay, right, because we made that transaction. I mean, arguably, like, we could, when we make this transaction, we could look up these names inside this other list. Actually, let's do that. That's going to be nicer. Maybe this will be a real project one day. So A's name, B's name, amount, and then we're also going to need the dest so we can change these. We'll do a mutable borrow of that. And you're sad, don't be sad. Okay, we need transaction new. So down here, transaction, and this is going to take in actually screw the lifetimes. I know I'm going back on this and the code will be less efficient, but whatever. Our n is like 5 here. So O of n heap allocations is lightweight. B mute. Actually, we'll just do a slice of records. This will return back self. So then here, this is pretty easy. A, B, amount. Let's copy. Okay, I should use these names to make it more clear. Alright, and then we can get rid of this. Okay. So, from to amount, the record. Okay. So then in here, this gets dirty. So now we have to loop through dest, find the matching name, and either subtract or add. We could write a lambda or some other like helper function. Ideally, we should have basically a struct for these records, right? Where we can just say, oh, this person's paying this, and it looks up both, or maybe we have indices so that it can't fail, right? Because here we're just searching for string names, which maybe we screw that up and call this with the wrong thing. But for now, it doesn't matter. R in if R is it name? It or mute, right? Because it's a slice, right? No, it's a record. So if r.name equals from, then r dot. So if this is from, we're sending it. So we want to subtract how much they owe, right? And then we're going to do the same thing here, except if name equals 2, then we're going to give them that money, right? Okay, and now you're sad, but that's fine. We don't need to borrow. We'll make clones on the heap everywhere because we love inefficiency. Okay, sweet. Okay, that works. And it subtracts. Oh. Problem is in here. Source is kind of useless. Huh. Okay, to have one borrow, we're just gonna do. We can't have it auto borrow for us, so this is just going to be for I. We'll just use a dummy for loop, 0 to I. And then to push, we need mutable. We'll just do let. We'll have a scope. And if it is a transaction, oh, and then we can use indices. Nice, okay. So if it is a transaction, we can do this, right? Except instead of here, we can do I, J. Oh, actually, we'll just do amount. Maybe amount, and then we don't need this. ij. Right, this gets a lot nicer all of a sudden. Let me just format this a little better. I don't like all the branching here, but whatever. Okay, this is still mad, but so B is going to be source I, A is going to be source I. How are these unstable? Push. Do we need another one of you? No. Why are you sad? This is a push. Huh. Huh. Oh, there's an extra. That's funny. Okay. And this is going to be from usize. Right, so these are indices inside record. So if, oh, and now we don't need to search, right? Now all we have to do is dest so the from person who's sending it, they're going to be dot they has paid has received, right? From to where does the borrow of dest occur? Okay, the nice thing is, other than these renaming errors, we can actually use lifetimes here again, because all the lifetimes are contained in this, right? So we can change these to be borrows with the same lifetime. We'll just call it tick-s. Yeah, and if I was using something like Python, and I wasn't really concerned about performance, this side would be a lot faster, right? But that's not exactly what I'm going for. I'm a massive narc for performance, so this is where it's at. Okay, from to. Okay. Okay, no, you're bad. Ooh. Never mind. We'll use strings. I promise, I promise. We'll refactor to this. Yeah, it's too bad Rust doesn't have small string optimization, because these strings are pretty short. Now let's make dereference. No. Lifetimes go away. Sweet. You don't build. Okay. Very nice. So why are you crying? Oh, because this is already a borrow. And you're mutable. Okay. Sweet. That works. So if we... Let's see what happens, because I have no idea. Okay, so it made 2 transactions. Vedant just pays himself and owes nothing. Good shit. Okay, this isn't working. From to... And Gabriel pays himself. Very nice. Yeah, this is by far the best strategy, to just pay yourself and owe nothing. But why does that not work then, right? Because IJ... So, if someone owes money, we can... What the hell's take care of this, right? So if someone owes something, if person A owes something, this is I, this is J. If the names are the same... Oh. Why are you paying yourself, bro? Oh, this is probably a bug, yes. The transactions were right, the names were just wrong. Okay, so Vedant pays Ashwin $11. So if I cat out the input file, Vedant starts with $11. Ashwin is owed $23. At the end, Ashwin owes $11. Okay, that works. Nice. And then Gabriel pays Jeffrey. Interesting. Why don't... How does this logic work? Oh, it must be the inner loop. Okay, yeah. Because I'd say, okay, if I'm first, why don't I pay the first person who... Oh, because Jeffrey would be the next person. And so it loops on Jeffrey and then loops on Vedant and then pays him. That kind of sucks. Yeah, this algorithm is garbage. So that at least settled 2 people, right? By making like stupid full transactions, right? But that's still progress at least. It'd be nice to have it prioritize paying. That's interesting. So then at this state, maybe we do another round of this until we can't anymore. Maybe that's the algorithm. Okay, yeah, I think multiple rounds of this should actually work. And we're going to do let transaction, no, not you. Transactions added, and then down here when we push, we're going to increment that guy, and then here at the end, right, if we went through a whole loop without being able to settle anything more, then we'll just break. And that did nothing. Nice. Why aren't I paying anyone? Or Julian paying anyone? What if we just flip this? Now we get a fuck ton of transactions. Interesting. Wait, does this solve it? Oh, I forgot less doesn't work. What do we call it? Settlebot. No. No, I want to see the top, buddy. That's not head. Fuck, that's not head. Damn it. Yeah, these are just stupid. Like, what is this? Okay, so maybe we only do it if, instead of money epsilon, we'll do like this. And then we make this value bigger. Because obviously we'll want a different epsilon in the future. Actually, I want to keep, I don't know how to spell epsilon, right? So I have to keep the string in the code. Don't have to search it up again when we do need the constant again. I'm just going to stick that here. And then you are going to become some massive, this epsilon must have killed it originally, right? So we're going to say we only want people to send $10 or more on the first set of transactions. Why are we paying this? And to pay is less than B's.credit. Man, I suck at coding. And we set this to 0 every iteration of the loop, yep. Oh, what? That's stupid, it gives us the same thing. Maybe we do want to search the whole space. That might be the issue. Okay, there we go, we got another one. I'm paying up now. Okay, and this is, I mean, this is still can do better, right? But this is pretty close to settled. So, what do we do from here? So I think this is kind of shitty, but for like a first loop, this is all right. What if we set this lower? Okay, same thing. Interesting. So this might be overfitting, but maybe we have a mode where if these are really similar, right? After someone gets paid, maybe we do this loop and then we have a second step here before we check this, where if amounts are similar, then we just make this transaction, right? Yeah, that's kind of garbage, but let's do that actually. And we could totally abstract this into like, have some function that does this iteration for you and checks for this, and like gives you these two and like lets you add transactions easily. But whatever. How much time would that take? Yeah, let's do it. So this is gonna take, it's weird because now this is sort of like a suspendable thing, so. So this is kind of where we are in the iteration in like the 2D loop. That's gonna help us calculate I and J. Is it just index? And we're gonna do this weird thing where it's item is gonna be, what does this iterate? This is sort of like gonna be a pair. Okay, and then we're also gonna need And we need lifetimes. Fuck. But this takes in. This is literally gonna be this type. What? Transaction iter. You will need this. What? No. When did that get changed? Oh shit. Boop boop boop. Okay. You are owed. And you don't need this. Okay, so this is going to iterate and give you a pair of matches, sort of. And then you get to decide if you want to create the transaction or not. Okay, so we're just going to have another impl here. That's not iterator. And this is going to be like transact. And so this will just take the current thing and let you transact off of it. So it's going to take in self and the amount. And this will do sort of what this block does. Okay, this will also have to take the list of transactions. And so we're just going to have fn ij. I know this is really garbage naming, but whatever. And the I is going to be self index mod and this is going to be divide. Right, okay, and so then this add will stick it in here and transact these and copy the names. Okay, cool. So this should make the code quite a bit cleaner, right? These now we'll do a new function, why not? So the new will set the index to 0 by default. We need dest. Now we'll have to do that. And transactions. And here we're going to need an fn new that takes in dest and transaction transactions. I should have just copied the types here. I'm a big dummy. Okay. No, what? So we're gonna need tick t for how long this lives. And then this is going to need tick T, tick T, tick T, T. Okay. I'll make you stop crying. Okay. Let's go unwrap right. Interesting. Okay. So, dest is already this. And is this a slice or is this a vec? No, you're gonna need to be a vec, buddy. You're gonna be a vec, a slice too. You, bye-bye. Okay, so now most of this loop boilerplate should go away. And we're also gonna need down here, okay, let's implement next. So if this is none, this isn't going to be very optimized, but whatever. We're just going to recurse if it's the same. Otherwise, if right, and so we know we're at the end. And when do we increment this though? We have to increment before. So if it's none, else, actually we'll just index right, near good. Self dot. Yep, okay. Okay, so we incremented the index. This ij will then work or whatever. And so if we've reached the end, if we've done the whole square of everything. Otherwise, we return some self.dest I spell unwrap. Hopefully the bar checker will be okay. It's not. Fuck. How do we know this is safe? I don't think we do. So this needs exclusive access, so this can only be called on one thread. And I think we need to just dereference this here. Right? Because these will live as long as this, but the thing is we never mutate dest in this vector. Do we? Why is it mutable then? Aha. Thanks, bar checker. Okay, so this should be correct. Now we should be able to actually loop. So A and B. It'll handle this. The maybe amount we don't have to worry about. These are the borrows. This will go away. And instead of having this if statement, if we want to pay, we can get rid of all this code and we just do transact. Yeah, the bar checker might still be sad about this, but we'll work through it. No way it's happy. We'll make this a cell. That's what we'll do. It's a little dirty, but it's fine. So it gets it, runs the function, and sets it, and then it returns. This returns the new value. Okay, so this is just gonna be O minus amount. No. That's unfortunate. So when we're paying, we're subtracting the amount we're owed. Yeah, so this is when I pay someone. So I'm subtracting the amount I owe from this. Okay. And this will be this. And you no longer need this because of cell. And you should work. Nice. Okay, that's the same as before. That's actually pretty cool. And the code is way nicer. So we'll create another iterator to it once we're done. The bar checker is still happy. And so now we are solving this issue where if there's transactions that are close enough, we just execute those ones. In the future, it'd be nice to have a library that like comes up with the candidate transactions and then does stuff based on that. But this is annoying. Okay, I have 10 minutes, so this probably isn't going to end well, but we'll see. So if okay, but it's not absolute, right? It's if how do we make sure this is negative? So if A's dot debt, so if this person owes money and plus how much this person's plus this person's credit is less than this is really overfitting. I'm doing one because it's exactly the amount we need for this to work, and is less than money epsilon, then we do this. Actually, this. A.debt plus B.credit. Are these not close enough? I mean, we're iterating both ways, right? Yeah, we go up until, yeah, huh. That's weird. Debug diff. Yeah, it's literally 0. And this is positive. Oh, how is this? What? Bruh. Are we returning the right stuff here? Yeah, we have to in order for these transactions to go through. Credit, self.owned, as paid, as received. Parse. I mod j divide. This is here. I j. I don't know why you're sad. Huh. Let's move this in here so we avoid the unwrap. Should get the same thing. That's so weird. How is it that we literally compare to this and then it fails? Oh, maybe these are when someone has nothing to pay. Right, this has to be a thing. And we're running this after this. Right, unless this math is wrong. So it should be one of the last two iterations. We should iterate this both ways, right? Where we try to make A pay and then make B pay, because we do the whole matrix. Huh. Unfortunate. That's really unfortunate. Huh. It's kind of sad I can't get this basic algorithm working. Oh! That's gonna add transactions forever. That's not good. So So if the amount this person owns is greater than money epsilon, and the difference between them when it's settled is less than money epsilon, this should work. Yes, okay, we get another transaction from Gabe to Nick. Nick gets 66 extra cents or whatever, but we're getting closer. So now Julie knows this and Ashwin owns this. So if we just make Julian pay and split it to this. Wait, why doesn't that sum? That is strange. That's a little scary. Huh. So we lost money somehow. Yeah. It's not good. Very sad. Yeah. Why doesn't this add up? Okay, well, it's about time. I have to go anyway. So, work on this a little bit later. Hopefully, I can think of the bug while I'm hiking, and we'll finish up. So, until then, stay frosty.